All right. So looks like we have a couple more people than last week. Bonnie and Justin, I think you were new this week. So let's quickly introduce each other. My name is Harry. I'm an upcoming grade 10 student at St. George's School. So Bonnie and Justin, which grades are you in?
I'm in grade 2, turning to grade 3.
Yeah, cool. And Bonnie?
7. Hi, I'm in grade 7.
Okay. So we have a range of age levels in this class. Camille, you're turning grade 5 or grade 6? Grade 5. And Justin and Bonnie, do you have any previous experience with programming, or are you new?
I have not. So this is new. Yeah.
Kind of. Not
Are
really.
you familiar with Scratch?
No.
Okay, then we're all on the same level then. So let's just quickly review what we did last week in our first class, where we got introduced to Scratch. So this was the project that we ended up with. If you look on the right, you'll see a white area with a couple of pictures of a cat and a ball. This area is called the stage, as we mentioned last week. The Scratch controls, which are the green flag button and the stop button, are located at the top left corner of the stage. So the user can click the green flag button to run the script, which is the code that the programmer inputs to Scratch, which can be found on the left. So this whole section is the code section. And if we click green flag, we'll be able to see our script in action, which looks like this. So last week, we began by making a cat, the cat, which is the built-in character in Sprite. It's the character that every blank Scratch project that you create has by default. So we added a few scripts to the cat character called the cat sprite. Scratch characters are called sprite, which made the cat move horizontally around the stage. So the cat would walk first to the right-hand side of the screen, then turn around, then walk back to the left-hand side, then repeat. And the code for that looked something like this. So if you look at the code area here, which contains all the instructions for a sprite, as we mentioned last week, all the instructions for the sprite are represented by blocks, which are these or these. The left side, called the palette, contains all the blocks we can choose from to add to our code. This area is called the palette. And if we want to add a command to our sprite, we simply drag and drop. And different commands are categorized in different sections. You can go to a section by clicking on the colored tab on the left. For example, the blocks in the motion tab make the sprite move in some way. And the blocks in the event and control tabs are special in that they don't represent a single command, but rather they tell the sprite how to run the other commands. For example, we saw the when green flag clicked block last week. So when we drag this into the code window, this block, the when green flag clicked block, would cause any block that we snap right underneath it to be run whenever the green flag is clicked. So for example, if we do this, then you'll notice the cat has two scripts that begin with a when green flag clicks block. And both of these two scripts will run whenever we click the green flag button. One of these scripts will cause the cat to walk straight and turn around when it hits the wall, which is this script. And the other script will cause it to point towards the ball whenever the green flag is clicked. So it looks like this. Do that again. And we also learned to change the moving behavior of the cat by, for example, making it always point towards the ball. For example, if we move the point towards ball block into this forever loop, which has the function of running repeatedly a sequence of blocks, this will happen. The cat will continuously move towards the ball. And every time the ball moves, or more precisely, every time the cat takes a step, it will make sure to face the ball's new direction. And now let's review the blocks that we used last week, one by one. So as we saw last week, the point in direction block makes the cat point in a specific direction. 90 degrees means to the right. 0 degrees means up. Negative 90 degrees means to the left. And 180 degrees means down. Hello. And the next block, the set rotation style block, this determines whether the cat can flip around. For example, whether the block can turn all around or whether it can only flip left to right. And we saw that if we set this to all around, and we tell it to turn around whenever it hits the edge, and we remove this block here. Then the cat will actually flip upside down whenever it hits the edge. And instead, if we set it to left to right, then it will only flip left to right when we hit the edge. We've just mentioned the forever loop. We also learned the wait block, which tells the script to wait a certain number of seconds before it continues on to the next block. This is found in the control path. And so, for example, when the cat is in the forever loop, it will move 10 steps, check if it's touching the edge, switch to the next costume, and wait 0.1 second before starting the loop all over again. And of course, we briefly looked at the costumes and sounds features of Scratch. So each sprite has a number of costumes and some sounds. The costumes determine how the sprite looks. So the built-in Scratch cat has 2 possible costumes. And when it switches quickly between these costumes, the cat looks like it's walking. And we can use the next costume block in the code. It's in the Looks tab here to tell the code to switch costumes for this cat. And finally, we learned how to add multiple sprites or characters to our project by using the sprite chooser, which is the cat head button at the bottom left corner of our screen. This takes us to the sprite library of Scratch, where we can choose one of any number of built-in Scratch sprites, each of which has its own costumes and its own sounds. And last week we added the ball. And when we added it to our project, it contained no code, but we could add code individually to our ball sprite too. So we added this, which made the ball continuously move, rotate, and bounce off the walls. And one final note, the scripts in 2 different sprites are independent of each other, which means no matter what we add to the cat sprite, for example, the code in the cat sprite only affects the behavior of the cat, and the code in the ball sprite only affects the behavior of the ball. So today, we're going to start a new project. Hopefully this will be a bit more interesting. So unlike this project, which we finished last week, our project this week is actually interactive, which means the code interacts with the user. The user can use the keyboard, for example, to give commands to one of the characters in the project, which in this case is a game. And the project responds. So if we click green flag on here, we can use the up and down arrows to make this sprite, which represents the player, move. And if the user presses the space bar, the space button, it will make the sprite kick a ball. Notice how the ball appears when the user presses the space bar and disappears when it hits the butterfly. And of course, you'll see this butterfly, which rotates and falls from the right side of the screen. And each time it's hit by the ball, it will say ouch. So I'm going to walk you through the first part of this game, which looks like this. And I'll leave it to you to add the butterfly. So let's start by going to the Scratch website, scratch.mit.edu. Do all of you have a Scratch account? Justin, Bonnie, do you?
Yes.
Yes.
I don't really know, but I never used Scratch before, so I don't think so.
Okay, then if you don't have a Scratch account, you can just click Join Scratch at the top right corner, create a username and a password. It will ask you for an email address and a birthday. So put those in and you'll be all set.
Okay.
Meanwhile, for the rest of us, we can click on Create on the mini bar. And this will take us to a new blank project. We can give it a name. I'll call it Lesson 2 project. Notice how now we have the cat, which was the project, which was the sprite we had in our previous project. But now we don't want the cat. We want another character for the player. So we're going to click the trash can button here, which will delete it. Now we have no sprites on the stage. And Justin, are you done making an account?
How actually I don't even know how to still can listen to the Zoom and go to Google.
Are you
just a
using a
second.
computer or an iPad?
Computer.
So if you double click anywhere on the meeting, if you click twice anywhere on the meeting.
Oh, I see.
Yeah.
Can I make that? Can I make it more smaller too, or that's the biggest?
You can just go to your web browser, like Google Chrome.
Wait, how to spell scratch?
SCRATCH.
Oh yeah, okay. Okay. Mustn't done that one. Password. Do you know where's Canada on which country you live in?
It's sorted by alphabetical order, so it should be near the top. If you can't find it, you can just click.
Okay. One. Yeah. Mama, 过来 email. Oh, sorry about that.
No problem.
No?
In the meantime, for the rest of you, we can start by creating 2 sprites from the Choose a Sprite panel, which we've just saw how to use.
Okay, so.
Are you there?
Okay, I'm very cool. Okay. So add another sprite.
Yeah. Okay. So you can really choose any sprite you want, but I'm going to go with something like this.
Choose a character.
Yeah, choose a sprite. It's this button right here.
Anything? So like,
Yeah, anything.
I'll just get another bar.
This is a bit too big, so we're going to make it smaller by changing the size value down here. Say, I'll make this 50%. A bit too small, say 65. Once you're done choosing your sprite, you can have a look at the costumes tab. Mine says 4 sprites, 4 costumes, sorry.
Costume.
We want the sprite to look like it's walking. So for me, I'm going to get rid of these 2. For you, might be different. And so if we switch quickly between these 2 costumes, it might look like it's walking.
I'm kind of stuck here for some reason, so I can't really see your page. And
Okay. Do you have the sprite?
oh yeah, I have 2.
You have 2.
妈妈小点声，我都听不见了。Okay, so I have 2 sprites. All size 65. So what I do now?
Yeah, if you have a look at the costumes tab, which is on the upper left corner,
Yeah.
you can see all the costumes that your sprite comes with. And if you don't want some of these costumes, you can click the trash can to delete them. And we want to make our sprites look like it's walking. So you can choose your costumes that way. And meanwhile, here's the important part. We want the sprite to move according to the user's keyboard input. So in this game, as we mentioned, the sprite moves using the up and down arrow keys. And there are actually blocks in Scratch that detect whether the user is pressing the up and down arrow keys. These are in the events tab. And right under when you flag clicked, we have when key pressed. So this block here behaves kind of similar to this block because for example, if we snap some other blocks under these, in both cases, the yellow block.
你知道我怎么把这个放大吗？
In both cases, the yellow block makes the following segment of blocks run whenever an event happens. For this block, that event is the user clicking the green flag. And for this block, that event that triggers the running of the rest of the code is the user pressing a key. And if we click on space, we can see all the keys on the keyboard. And we can change this to up arrow. And we're getting rid of this. So now we have this small script, and we don't even have to worry about pressing the green flag button because this block makes this script run whenever the user presses the up arrow key, even if the user hasn't pressed the green flag button. So if we now press the up arrow key, we'll see it moves until it hits the wall. Well, that's not really what we want. We want the sprite to move up and down, not left and right. But still, we don't want to change the direction it's facing in, because that happens. So we still want the character to be facing right, but we want it to move up and down. We do this by changing the Y value of the sprite. So last week we explained what the X values and the Y values of the sprite mean in Scratch. So you can think of this stage as a grid system. See here. We can think of there being two perpendicular axes on the stage, which indicate how and the location of each sprite can be expressed by how far it is along each of these axes. So the horizontal axis is called the x-axis, and the vertical axis is called y. When the sprite is right in the middle of the stage, we say that it is at x0, y0. When it's far to the right, you can see that the x value has changed to a large positive number. And when it's far to the left, the x value has changed to a negative number. And if it's far up, the y value is positive. If it's far down, the y value is negative. And somewhere in between, then both the x and the y values are different from 0. So how we're going to use this system is here we're going to be concerned about the y value. We want the y to make sure that the sprite moves in the vertical direction. We want it to change only the y value. And as we've just seen, increasing the y value makes it go up. For example, right now it's 10. If we make it 20, it goes up. If we make it 30, it goes even higher. While if we make it, say, negative 10, it goes down. So there's a block in Scratch that changes or increments the y value of a character. This is the change y by block. This is the motion tab. If you click on the blue circle at the left in the palette, you'll see all of these blocks, some of which we met last week. And we can drag the change y by block into the code area. And we can get rid of the move 10 steps block by dragging it into the palette. Snap this here, and there's our script. Whenever the user presses the up arrow, it changes y by 10, which means it moves up by 10. And it works. And we're going to do the same thing, but for the down arrow. So I'm going to show you a trick. In Scratch, if we want to make two similar scripts, we can click anywhere in the script and click duplicate. And that will make a copy of that script. And we can change the up arrow to down arrow and 10 to minus 10, which means that the sprite goes down. So now we have two scripts. When up arrow key pressed, change y by 10, go up. when down arrow key pressed, change Y by -10, go down. Let's test it. And it works. Are you all here?
Yeah.
Okay, we also mentioned changing the costumes of the sprite to make it look like it's walking. We saw how to do it last week. Sorry, here with the next costume block. And we're going to use the same block here. We're going to put it underneath each of these so that the sprite will switch costumes every time we press up and down.
Okay.
This looks a bit awkward, but it works. And now we're getting to the next part. The ball. So as you saw in our demonstration, the ball only appears when the space key is pressed, and it disappears whenever it hits something, for example, the butterfly or the wall. And it reappears and goes down to the character whenever space key is pressed again. So let's create a new sprite and make it the ball. I'm going to have fun with this here and making an apple. We're going to make the apple smaller as well, say 50%. Yeah, that's good. And we're going to put it anywhere. And so in our demonstration, we saw that whenever the ball of the user presses spacebar, the ball goes to the character. And as the character moves, the ball still goes to the character's new position whenever space key is pressed. And we can do that here. Let's go to the Events tab, which is the light yellow circle, and put another one of these when space key pressed buttons here. And we're going to leave this as space. So when space key pressed, we want the apple to go to the dinosaur. So we go to the motion tab and we use the go to block. It says go to random position. We want it to go to dinosaur or whatever your other sprite is called. So let's try it. Yep. And yes. And of course, we want it to disappear whenever it hasn't been kicked. So we can make it disappear right here. This is near the top, near the bottom right corner of the screen. It's the show button, and we're going to hide it. And whenever the space key is pressed, it's going to show. And we can make it show by going to the Looks tab and using the show block. And now we're going to make it move towards the right side of the screen. And we've already seen how to do this. We use not a forever loop, but a repeat until loop. This is the control tab. The difference is that forever loop makes it do something forever, and the repeat until block makes it do something as long as something else is not true. So in this case, we wanted to repeat, go to the right, as long as the ball is not touching the edge. We're going to put this here. And we're going to introduce a new tab altogether called the sensing tab. This contains all the block that the ball can use to sense its surroundings. And we're going to use the touching mouse pointer block. And of course, we wanted to detect not the mouse pointer, but the edge. So we have something like this. Repeat until touching edge. And as long as it isn't touching the edge, we want it to move. And remember how I just showed you that the stage can be characterized, can be described in terms of two number lines, two axes? Well, now we use the x-axis to make the apple move to the right. Because the x-axis is the x value determines how far the sprite is horizontally. And to do that, we go to the motion tab and we use the change x by block. For example, change x by 10 makes the apple move to the right 10 steps. And we can try that if we press space key here. And that works. We can also make the apple rotate while it's being kicked by using the turn degrees block in the motion tab. You can make it turn clockwise or counterclockwise, it doesn't matter. And we're going to put it right inside the repeat until block with the change x by block. And 15 degrees at a time is too much. We can change it to maybe 5 degrees. Nope. 50 degrees is better. And yeah. And we'll remember to make the apple hide after it's done hitting the wall. So our script for the apple looks like this. Yep, that looks good. So the next challenge for you guys is adding the butterfly. If you saw here, the butterfly, right, can be chosen in the sprite chooser in Scratch. It's somewhere here. Butterfly. For fun, I'm going to use that instead this time. And so what you need to do is first make sure the bat is the right size, and next make sure it keeps falling down from the right side of the screen. So the bat starts here, it falls down, and when it touches the bottom edge, it goes right back up, falls down again, and it keeps changing costumes. Do you know how to do that?
Not really.
You can refer to the Apple sprite and see how it has a change X5 block inside a repeating loop.
Oh, yeah.
Yeah, you can try using a change Y by block inside a forever loop for the back sprite. So I'll give you 5 minutes to make the bat do what the butterfly is doing here. You can also make it rotate as if you want. And if you're done or if you have questions, let me know.
So it is forever.
Yeah, forever.
Okay. Permitted to change X.
Are you all done?
No, I just have a question. How do you like make the butterfly again go to the top of the top and then go down to the bottom and go to the top again?
Go to the motion tab. So, and I'm actually going to walk you through this now.
Excuse me?
I'm just going to demonstrate how to make this script.
Okay.
Yeah.
Thank you.
So this time, we don't need the user to press a key to make the bat move. So we're just going to use the when things like click block. And right after this, we snap under it a forever loop. We want it to keep going down. We saw this here, where we used the change Y by block to make it go up or down. And here, we can do the same thing. We can use change Y by the sum minus 10 to make it go down. And we can make it rotate as well.
And how to make it go up? Yeah.
We're going to introduce a new block, the if then block. So we want it to go up, go back to the top whenever it touches the edge.
Yeah.
So we use the if then block. If touching edge, then go up. The touching edge block is here in the sensing tab.
Yeah.
We make mouse pointer edge. If touching edge, then we go to the motion tab and we use this block. Go to X something, Y something. And by default, the X and Y values always represent the position that the bat is currently in. So if we move the bat somewhere, you'll see that the X and Y value have changed. So if you move the bat to a starting position and then drag the go to X, Y block here, then that should do the trick.
Okay.
A bit too quick. So we're going to use the wait block. Put it right here, for example. Make it 0.05 seconds. And we also make it change the costume of the bat every time it takes a step. A bit too slow. 0.01 seconds. We'll get rid of it. Okay. So now we have the bat. And the last step is to make the apple be able to detect if it's hitting the bat. So we go back to the apple. And now we want it to disappear if it either touches the bat or the edge. So we change this from touching edge to touching edge or touching bat. The or block is in the operators tab. It's here. You put touching edge in one of the slots, and we drag another one of those touching blocks in the other slot and make it touching bat. And we put it back in the repeat until block. So now the ball will disappear when it either hits the edge or hits the bat. And now for the last step, we want the bat to say
Ouch.
ouch whenever it touches the apple. We're actually going to make a new script here in the bats. We're going to start it with when green flag clicked. We're going to add a forever loop so that it keeps checking whether it's hitting the apple. We use an if then block, which we just saw here. And instead of touching edge, we put touching apple. And the part where the bat says ouch is located in the looks block. Say hello for 2 seconds. That's it. And we change hello to ouch. Run the code again. And this time, it's difficult to see, but the bat is saying ouch.
Your bat is so fast.
It is. We can make it slower.
I try using wait 0.050 second. It works pretty well. I think I'm finished now.
Is everyone else finished?
I accidentally deleted my code, so I just needed to redo it.
Okay.
I didn't use the animation because I used the butterfly too, and the animation is with flag or yeah, it's just very weird.
Yeah. If you want to refer to my demonstration project, I can just put my link in the Zoom chat.
Okay.
And there it is.
Can I post it to public or something?
Yeah, I just did that by clicking on the orange share button here.
Oh. Okay.
And so lastly, I'm going to show you something interesting about costumes. So what we just saw is that whenever we press the spacebar, the apple starts right around here in the dinosaur. So that's where the center of the costume is. And the apple, and whenever we tell the apple to go to dinosaur, we're actually telling it to go to the center of the dinosaur costume. But the thing is, we can change where the center of the costume is. If we go to dinosaur and go to costumes, we can click, for example, Control A or Command A, and you can move the whole thing around. And while you're moving it, while you're dragging and dropping it, you can see a crosshairs right in the middle of the sprite. And you can move it, say, to the head.
Okay. home.
right at the mouth, or maybe here. And do the same thing for the other costume. Yeah, so now, oh, whoops. One second, slide adjustments. Now the apple always starts at the dinosaur's head. And if we want to add some cool animation, I just deleted the costumes, but I can add them back.
I think my tab is kind of glitched.
Should be fine. Do you still see the product?
Yeah.
Okay.
I'm gonna fix that.
So I can copy this to and put the center at the head again. And now what we want to do is to make the dinosaur walk. We switch between the first two costumes. And to make it kick the apple, we make a switch to this costume briefly before going back to these two costumes.
Okay.
And we're actually going to make the center here so that
I can see how it works.
actually I'll keep it here and move the other two. Okay, so we're going to not use the next costume block. Instead, we're going to use an if-else block. So when it's walking, we wanted to check whether it's in costume 1, for example, or in another costume. If it's in costume 1, then switch to costume 2. And if it's in some other costume, then switch back to costume 1. So you can do this here. If costume number is equal to 1, then switch costume to the second costume. Otherwise, switch it back to the first costume. And we just copied this here. So we have this. And when spacesuit pressed, we switch it to third costume. Say wait 1 second, then switch back. Let's see how this looks. Yeah, that looks good. Are you all finished with this? Yeah, so if you're not done, you can finish this in your own time. This link will always be available. And I actually have a Scratch folder or a studio that will contain all the projects, all the demonstrations that you will need. I'll put it here, and I'll make sure to add our project today into there as well. And if you want to play around with the costume editor, for example, you can change, for example, the shape of the mouth, move things around. Or add drawings. You can do that. And you can also change the backdrop or the background of the stage by clicking on the stage and drawing something like a ladder or the dinosaur. If you want to. You can also try to make the apple fall down while it's moving as an extra challenge. And that will be it for the session. See you next week. And thank you for coming.
Thank you.
Thanks.
I think I woke up.